All right, so we solved several types of equations as far as linear equations, and we're going to expand our understanding into solving equations with absolute value. So think about what you know already about absolute value, and especially the definition of absolute value. Definition of absolute value being the distance a number is away from zero. So when we're thinking about absolute value, we have to remember things like, okay, when we have the absolute value of 6 and we have the absolute value of negative 6, that both of those are equal to the same value, the 6, because that's the distance from 0 for both of those numbers. So when we look at absolute value equations, and what we mean by absolute value equations is the variable occurs inside an absolute value, we have situations that look like this. So these are just very basic to kind of get our feet wet on this idea of absolute value. But remember, we're trying to solve for x and say what values of x would make the equation true. So when we look at the absolute value of x equals 7, we think about what value would go in here. And we think about what this means as well. If we think about the number line, here's 0. What numbers are 7 away from, or what numbers would have an absolute value of 7? Well, that would be positive 7, a point on positive 7, or a point on negative 7. So when we're solving here, we actually have two values that would make this true. The absolute value of negative 7 and the absolute value of positive 7. So our solution would be that x equals 7, or it could be either one of those. There's two numbers that actually make this equation true. So same thing if we're going down here and we're thinking about 30 and we think about that number line. 0, what numbers are 30 away from 0? Well, 30 and negative 30. So x could be 30 or x could be negative 30. And we can also write this, since we've seen this notation, I'm going to write some of the answers this way. The squiggly bracket here just means that there are possible answers, 30, and we separate them by commas. 30 and negative 30 are possible answers. Now this last one, absolute value of x equals negative 5. Okay, so think about, again, what's the definition of absolute value? Well, it has to be a distance, and a distance can only be a positive number. So in this case, how could you be negative 5 spaces away from 0? Well, you can't, because this absolute value only equals a positive. So this answer is actually that there is no solution. So when it comes to absolute values, what you should notice is, so these are the most basic equations we could see right now. But what do we notice when we solve these problems? First thing is, when there is a variable inside an absolute value, it's possible, so not there are, it's more it's possible that sometimes there's not. There are normally, though, two solutions. And why is that? It's because of that nature of absolute value, where negative 7 and positive 7 both have the exact same absolute value. So a number and its opposite have the same absolute value. The other thing we notice is an absolute value, if it's equal to a negative number, there actually isn't any solution. So this will come up from time to time, and this idea of having no possible solution shouldn't be too foreign to us at this point. The question I want to ask you just to think about is, can you think of a situation where there would be only one solution? So you could think of a very simple example like with the ones we have up at the top. And we'll come back to this at the end of the video. So I just kind of want you to think about, is that possible? Is there an example where there would only be one answer? Okay, so as far as solving basic absolute value equations, so thinking about our example here, the absolute value x equals 7. What has to be true? And so I want you to kind of ignore this piece on the inside. And actually, I think I want to change this to, I'm going to highlight this. This piece on the inside here, I almost want you to ignore that for a second and think just about, think just about what this is saying. It's saying, okay, there's a value on the inside of the absolute value, and it is equal to 8. So what has to be true about this value overall? For the absolute value of it to be 8, what has to be true about this is this has to either equal to 8 or it has to equal to negative 8. If you're talking about when we're going to take the absolute value, we're going to get this value out. One of those has to be true. So when it comes to dealing with absolute value equations, how we get our two answers is we deal with this equation in two ways. We say that either this inside part of the absolute value, what's inside the absolute value bars, has to be equal to the positive value, because if we took the absolute value of 8, we would get 8, or this x minus 5 has to be equal to the opposite value. It has to be equal to negative 8. So one of those has to be true. If it's equal to 8 or it's equal to negative 8, when we take that absolute value, it's going to equal to the number we want. So how do we get our two values? Well, we just solve our equations. So we have x equals 13, and if we add 5 to this one, we get x equals negative 3. So our two answers, we have 13 and we have negative 3. So we have two possibilities for answers there. Now if I plugged either of those in, again, absolute value of 13 minus 5, that's the absolute value of 8. And if I plug in negative 3, that's the absolute value of negative 8. So again, both of those, absolute value parentheses, are equal to 8. So now it's time for you to try one on your own. So pause the video and think about what we just looked at. So again, if we look at this portion inside the absolute value, what do we know has to be true? We know that either this equals to the positive value, or this portion has to equal to the negative value. In order for, because it has to be the absolute value of negative 4 or the absolute value of 4 is what we need to end up with to equal to positive 4. So solve each of these equations individually. And notice, so when I split that up, the absolute value bars are gone. By taking those two values, we have taken care of the absolute value and accounted for the fact that we're using absolute value to solve it. So I hope when I'm talking here, I'm actually solving these correctly. So the answers are either 1 or 5. And so if you plug those in, you can check and make sure that inside that absolute value, and if you remember, we called absolute value one of our grouping symbols, like those invisible parentheses, the absolute value is a grouping symbol as well. Okay, so when we look at, I wanted you to actually think about these special cases here, and this is to address the question I asked earlier. So pause and think about these ones really quickly, but if you look at this problem, x minus 7 is equal to, or sorry, absolute value of x minus 7 is equal to 0. When we talk about that number line, what number has an absolute value of 0? Well, the only number that has an absolute value of 0, that's a distance of 0 away from 0, is 0 itself. Wow, that was a lot of zeros. So when I do this problem, there is no positive 0, there is no negative 0. There is only one answer in this case, and that would be that x equals 7. So how do I have an answer or only one answer? That'd be a situation where it's equal to 0. Now in this one, you think about, again, you got to think about what does absolute value mean? An absolute value of negative 8 can't happen, so here my answer was 7. So here my answer is there is no solution. So you may be tempted to just go through the process, but you really have to have an understanding of what absolute value is talking about to do these problems appropriately. All right, so when it comes to solving more advanced problems, and this is my I do of an example, we still have to keep in mind that idea of absolute value. So here's our portion, and I'm actually going to go back to my highlighter here, not a black highlighter. And we have to keep in mind this absolute value portion of the equation. So what we really want to treat this as is almost like we're solving two separate sets of equations. And you'll see what I mean in a second here. But when it comes to absolute value, the idea of how we're going to do this problem is the first thing that we want to do is really isolate the absolute value portion. So the absolute value portion being the portion that I have highlighted below. So if it helps you at all, you might want to envision this equation almost when we're trying to isolate this as, let's pretend this is just a new variable here. and change this whole absolute value section to a y. That can help you see as far as how do I solve this. This is just to help you see what steps do I need to take. So in order to get the absolute value, again, so this y portion on our equation, in order to get this alone, what steps are we going to have to take? Well, we're going to have to add 6 to both sides. So this portion cancels out. I'm left with 3, absolute value of negative 2x plus 4 equals to 24. And then I'm going to take my 3 and I'm going to divide by that coefficient there. So I'm left with the absolute value of negative 2x plus 4 equals to 8. So from here, now I have an equation that I can actually solve. And again, so we have a negative here. You might want to be cautious about this and just pay attention. But the only place that we actually can't have a negative is that our absolute value can't equal to a negative number. So can we get a value of 8 from taking an absolute value? Yes, we can. We can get it from if the inside of this absolute value equals to positive 8. And we can get it if this inside of this absolute value equals to negative 8. So from here, I'm going to solve my two equations. So again, we want to get that absolute value portion alone, and then we want to solve the equations that are left. X equals negative 2, or negative 2x equals negative 12. So x equals 2 divided by negative 2, positive 6. So it's either negative 2 or positive 6. Okay, so we got one more for you to try. So take an attempt at this problem. Pause and take an attempt. All right, so if we look at this, trying to think about this like as an equation and isolating that y, isolating that absolute value portion, we're going to subtract 4 first. We didn't do anything with this negative sign yet, so I'm going to leave it. Negative absolute value of 2x plus 3 equals negative 9. So the absolute value is not quite isolated yet. It still has this invisible coefficient of negative 1. So I'm going to divide both sides by negative 1. So I don't really want to think about the absolute value until it's completely alone. Now that I have the absolute value equal to positive 9, and so before it was negative 9, but I don't really pay attention to it until I'm finishing the problem before I'm splitting the absolute value. So this problem becomes 2x plus 3 equals 9. And 2x plus 3 equals negative 9. So we can finish off the problem because our absolute value is equal to a positive number, which we know an absolute value has to be equal to a positive number. So finish off your two problems. You notice my solving steps are the same for both of them. I just end up with different, so if you do your calculations correctly, you end up with two different answers. So divide by 2, x equals 3. And we have a possible value of negative 6. So two different values there because our absolute value is equal to a positive. So just to summarize here, kind of as your final piece here, most absolute value equations do result in two solutions. And think about why. It's that positive and its opposite that have the same absolute value. When you have one solution is when you have absolute values where it's equal to 0. So think about just the most basic even. Absolute value of x equals 0 versus absolute value of x equals 2. If the absolute value has a negative number, absolute value of x equals negative 3, there's no way to have that because we're talking about a distance, and a distance can't be negative. We have to isolate that absolute value portion of the equation before you're splitting. So make sure you undo any operations that are around your absolute value on the outside, not on the inside. We don't touch those until we've split it into two problems. You want to almost think of those like, I don't know, like jail bars. You can't get in. You have to remove them first before you can actually touch anything on the inside. And so really what you want to kind of do is not think about this as a separate process, a separate set of equations. Think about how is this the same as, and how is this different between how we've solved linear equations thus far. We'll kind of brainstorm a few of these in class, but don't think of this again, it's a separate category. This has similarities, it's just kind of taking it to the next level.